Hi everybody, my name is John O'Reilly. I'm a software engineer at Neat. And the plan today is that we're going to demonstrate the building out of a basic Android and iOS app that uses the same shared Kotlin Multiplatform non-UI code and uses declarative UI frameworks, specifically Jetpack Compose on Android, SwiftUI on iOS for the UI. And the idea here is that we're going to build out, for the UI development, we're building out, we're using the best of breed technologies available to us on our platform, using the best IDEs, frameworks, libraries, and then obviously using Kotlin Multiplatform for the shared code. And just to give some background, the plan is to go through a couple of slides just to give some context, maybe for 3 or 4 minutes, and then we'll dive into coding after that. So I'm just going to level set on a couple of things. People here may or may not be familiar with Kotlin Multiplatform and Declarative UI, but just to give a very high level definition, this is from Kevin Galligan. If you've followed multi-platform at all, you're probably very familiar with Kevin and TouchLab, the sort of pioneers in this space. But a couple of key things here. First thing is this optionality, which is a critical aspect, that differentiates Kotlin multi-platform from other approaches. This ability to sort of incrementally use it for as little or as much up to the shared code as you want. And the typical advice is to start small, use it for some maybe remote API endpoints, some data model, for example, and build up from there. And the other key thing here is highlighted is that we're typically focused on the sharing of non-UI logic. So Kotlin Multiplatform is supported on all these platforms. In today's talk, we're going to be focusing on Android and iOS. The GitHub repository that this talk is based on also has implementations for for watchOS, macOS, JVM, web, and as of recently, actually Jetpack Compose for desktop as well. So you're I'll post a link on. So typically, in terms of interactions and posting information, I typically use Twitter. The Twitter handles there on the slide. So I'll post a link to the repository after this as well, if you want to sort of try out some of those other platforms as well. So just again, if you have followed Kotlin Multiplatform, you may have seen this announcement of Kotlin Multiplatform Mobile a couple of months ago. Just to explain, this is sort of typically, or it's primarily a rebranding by JetBrains in terms of just focusing on what is the key use case for Kotlin Multiplatform, which is on iOS and Android. As well as sort of updated documentations and samples, it also has this very nice Android Studio plugin now that you can use to generate a new Kotlin Multiplatform project, and also to actually run Android and iOS apps directly from Android Studio. So again, just level set on Declarative UI. You may have seen there's a couple of other talks earlier, and I think there's some more tomorrow on Jetpack Compose specifically, but Declarative UI is typically described as a sort of the what versus the how. In a declarative UI framework like Compose or SwiftUI, we describe or we declare what our UI should look like in a particular state. And any change in state, state is a very critical aspect of this. This approach. Any change in that state then will be reflected automatically in the UI. And in the Jetpack Compose world, people talk about sort of smart recomposition, this optimal sort of recomposition of the UI as the state changes. And this is in contrast, obviously, to traditional imperative approaches where we describe how to create the UI. And just a bit of background, Jetpack Compose was announced at Google I/O in 2019. It's an alpha release right now. It's available in Android Studio Canary versions. The SwiftUI was announced actually only a couple of weeks after that, but it was at a more advanced stage. It was available to download as a Xcode beta that evening, and that's actually how I sort of start down this path somewhat. And it allows building of user interfaces across all Apple platforms. And this is a kind of an interesting point. We talk about Kotlin Multiplatform, but in the iOS world and the macOS world, for example, there's the concept of SwiftUI Multiplatform, which is about using more or less the same UI code across all the Apple products. And we're starting to see that build out a little bit in Jetpack Compose, where we have Compose for desktop now, and we can build out sort of parts of our UI. And this was sort of a segue to the next slide. I was trying to create something that got across, I suppose, the emerging ecosystem that was developing around UI development now, where we've sort of converging on certainly declarative UI frameworks, SwiftUI, as I mentioned, across the Apple products, Compose, mostly being developed for Android right now, but now with Compose for desktop, obviously available on other platforms as well. And obviously then being able to use shared Kotlin Multiplatform non-UI code across all those platforms, which is pretty compelling. This is the repository which today's talk is going to be based on, People in Space. It was sort of designed as a sort of what I describe as optimally minimal, a project where I could sort of, at a glance, you could sort of get across, you could see the sort of the key moving parts of a Kotlin Multiplatform project. But at the same time, I wanted it to be non-trivial in that it still has access to users' remote API requests, stores data in a database locally, etc. And as I mentioned, along with iOS and Android, which we'll be talking about today, it also has implementations for other platforms as well, which obviously very welcome to try out. And if you look at sort of the official Kotlin Multiplatform docs as well, there's a link to this project from there as well. in fitting with the project as a whole, I'm going to be overusing the word minimal, but this is sort of the API that we're going to be using that today. It's sort of a very basic API that returns a list of people in space. There's also an API that returns, for example, the International Space Station, and the code that's in the repository also makes use of that as well. But today we're focusing primarily on this API and using this API in an Android and iOS application. So a very high level view on the architecture. Obviously below the line is Kotlin Multiplatform shared code. We have a data model repository. We're using JetBrains' Ktor library for remote API requests. This is very similar if you're working on Android, you're using something like Retrofit, very similar to that, but it obviously runs in multi-platform code. We're using a third-party library called SQLDelight, which for persisting data locally in the database. Obviously in Android and iOS, we have SQLite databases, and SQLDelight rather is a library that works against both of those, again, in a multi-platform code. And in the UI layer then, we're taking an MVVM approach. Nothing about Kotlin Multiplatform forces you to take a particular, architecture in terms of your UI. You could be using MVP here, for example. But in this example here, we're using MVVM. We're using standard Android architecture components, view model, obviously using Jetpack Compose on Android. On iOS, we're using sort of something akin to that on iOS and SwiftUI for our UI. And with that, let's switch over to some coding. Excuse me. So, I don't know if people follow, or if you've seen some talk from Bright Gardner. He's given a couple of other live coding sessions, I think, on Jetpack Compose, and he described sessions like this as like a cookery show where we have some stuff made fresh and some stuff prepared earlier. So in a very similar vein, we're starting here with a pre-existing project that we're going to build out, an empty project. But it's a good segue to another key point, I think, about Kotlin Multiplatform, and particularly if you're starting off Kotlin Multiplatform the very first time, it can be a little bit challenging getting all the dependencies correct, all the right versions. So I strongly recommend starting off with an existing project or template. You're obviously very welcome to use People in Space. It's useful maybe when you're looking at Kotlin Multiplatform the first time. There's also a very good project called CampKit from TouchLab that I strongly recommend if you're sort of going a little bit further then and you want to sort of see some more sophisticated, maybe better error handling and more different sort of scenarios around coroutine scope usage and things like that. But as I said, so we have an empty project like this. The idea of a Kotlin Multiplatform project like this typically is that we have some shared code. We have a common module, as we have in this case here. We have an Android app module. In our common module, this is using a Kotlin Multiplatform plugin that allows us to develop, as obviously Kotlin Multiplatform code, but in such a way that we can, also add platform-specific implementations of particular features if they're needed, and we'll see an example of that. So, for example, if we look at the source tree coming, from here, we can see that we have our common main, which is where hopefully most of our code will reside. This is our sort of fully multi-platform common code. But then we have sort of platform-specific source sets here, iOS and Android, and specifically in this context here. So what we're going to build out is we're going to add in a very, very basic API class, which represents our interaction to the remote endpoint. We're going to add a repository which wraps around that. Just wraps around, the API starting off, and we'll build that out a little bit more throughout the talk. We'll add a view model on Android and some compose code, and then we'll do something similar on iOS, and then we'll come back and make some more changes. So again, I'm going to be making use of Android Studio Live templates and iOS code snippets here, just so you don't have to watch me mistype a lot of code. But I will, as I bring in bits of code, obviously we'll use that to sort of explain various points along the way. So this is our kind of remote API class. We're going to start with some data classes which represent the JSON that we're getting back from this endpoint. So we're using another library here called Kotlinx Serialization, which kind of works alongside Ktor, which is, if you're, again, an Android developer, you're familiar with JSON and Moshi, for example, something that allows converting these data classes to and from JSON. And these are the data classes that map to the JSON, as I mentioned. So we're going to add in a class, and then and this is the URL that we're hitting. And we're going to make use of a Ktor class or library called, Ktor class called HTTP client. And this represents our interaction with the remote API endpoint. And in fitting with Ktor and other similar approaches, it takes a very sort of DSL type approach where we install our various features. So here we have a JSON feature which says that we want to use this Kotlinx serialization for serializing our JSON to and from our data classes. And we're adding a logger here as well. which is useful obviously as we're debugging this, or as we're we want to see some indication that our code is running. And for now, we're going to add a simple method here, which simply uses that client object to get back the data from the endpoint. Then if we go back to our repository then, so this is just for now going to be a basic wrapper around the API class. As I said, we'll build that out, we'll add persistence code later on, for example, but for now it simply delegates to the fetch people method that we added in the API class. The other thing to note here is that we're using Coin. I'm not too sure if people use Coin. It's, if you might be familiar with Dagger also. It's sort of a dependency injection framework. What's nice about Coin is that it runs in multi-platform code. So we're using that here to inject the dependency to the API class that we just added a moment ago. And that is the sum total of our shared code right now. We'll obviously come back and add some more to it. And having added that now, we can go into our Android view model. And again, if you're familiar with Android architecture components, maybe if you use the Android view model, it provides a number of capabilities. In this case here, we're using, for example, its implicit view model scope, lifecycle aware scopes, so that we can call suspend functions. In our repository class, our API method to get the data is a suspend function. So we can call that from here. And that's simply going to call that method in the repository in the shared code. And again, this is the people in space repository class is a class in our shared Kotlin Multiplatform code. And we'll see that same class being used in IS in a moment as well. And in this example here, we're using mutable state flow. Typically in our view model, we have some data which is observable in our UI. You may be familiar with using live data here. It's another interesting discussion, I guess, in terms of just transition we're sort of making, I guess, towards the use of state flow. But live data will work equally well here as well. But again, we're making sort of one-shot request here, getting the data back and setting in the people space. And then any code, in this case, it's going to be our Jetpack Compose code that observe this, then we'll get that update. We'll get notified then when that changes. Now, so our UI code. This is where, again, in a traditional Android application, we have activities, fragments, layouts, etc. For example, we have a simple activity here, which I'll get back to in a moment. But our Jetpack Compose code then, it looks something like this. Again, if you have used Jetpack Compose at all, this looks very familiar. But if you haven't, the idea is that our UI is defined in terms of Kotlin functions, Kotlin composable functions that have this annotation. And again, instead of using external layouts, for example, and fragments, our UI is fully encapsulated in a kind of a function like this. And our UI in this case is going to be a list of people in space. And for each row in the list, which is represented by this function here, we're going to show the person's name, the astronaut's name, and their craft that they're on. And you can see we're using constructs like row, column, texts, adding certain modifiers, styles for typography. Hopefully you see it's very readable. And when we look at the SwiftUI code in a moment, you'll see something very similar, maybe slightly different syntax, etc., but fundamentally the same approach being used. And having added that, we can now add in our main layout. This is pulling in obviously a little bit more code, but I'll go through this here. Key thing here, we're using this Jetpack Compose as scaffold, which so represents our screen as a whole. We're adding an app bar, which simply returns the title of people in space. In an application here, you might add an overflow menu or some icons to do something else, for example. And then in our body content, we have lazy column 4. And this is, if you're making the transition from sort of traditional Android development to Compose, this is sort of one of the things that stands out, I guess, the comparison. If you're using a recycler view, you're used to setting up adapters and view holders and various layout files. In Jetpack Compose, our list is simply a lazy column 4, where we iterate over all the list of people in our list, and we delegate then down to this composable function, which, as I said, renders the UI for each person. And in terms of our state, we saw a moment ago that we have this people in space in our view model. It's a mutable state flow, or state flow in our case here. Typically in the Compose world, we deal with state. Compose's concept of state, and the idea, as I touched on earlier, is that any changes in state then cause our UI to be recomposed. So there's a number of extension functions that Compose provide to allow you to take from state flow in our case, or maybe live data. And in this case here, we're using state flow, so we can use the collective state extension function so that it takes our state flow and converts it into a Compose state. Again, whenever then our state flow in our view model changes, our Jetpack Compose state changes and our UI is re-rendered. And this is kind of a critical part of this approach in general, and not specific to Compose. As I said, we'll see in a moment, it's the same approach that we're using in SwiftUI as well. And having done that, we can now if I remember to type the right one. And now we're using another extension function from that Compose provides. Instead of, again, in an activity, typically on Android, we have set content with our layout file. We now set content and we just invoke our main layout, and we're passing in the view model in this case here. And again, we're using coin to inject the view model into the activity. So if we run this, just as this is running, just to mention, the shared code, the common module that we had, when it's being used as part of an Android application like this, it generates a jar file then, which is obviously consumed as in our Android code. In a moment, as we see when we use it in iOS code, then that shared code using, obviously a different target than an iOS target, would generate a framework then, which is used in our iOS code. So we can see here our very basic UI here, the list of people in space, and we'll make it a little nicer throughout the talk. But at this point here now, we can switch over to Xcode, and I'm going to add in a view model here. And at a glance, if you scratch below the surface here, I think you'll see that what we have here is very similar to our Android view model. First thing to note is that we're using assignment, people space repository, and these are those same classes that we wrote in our shared code that we used in our Android view model. And we're using it on iOS here. We're using iOS's combined framework here. So again, the concept of observability, having a view model that represents some state that we can observe in our UI. Instead of our state flow here, we have this published list people array representing the same data. And we're using this repository. This is the people in space repository from our shared code. And we're invoking fetch people here. And if I switch back to the repository for a moment, just one thing to note here, we're using Kotlin 1.4 capability where if you add a suspend function in your repository or in your surface area that you're exposing from your shared code like this, that's automatically available then in your Swift or Objective-C code. And what it maps to is a result in an error. So for example, if an exception is thrown in that, then that will map to an error that we retrieve here. If it's not an error, then we get the result back. There's some caveats to this approach, and you see different approaches being used here where maybe we, instead of taking advantage of this capability, we might pass in a lambda or closure if perhaps we want more control over the coroutine scope and things like that. We can talk about that. If folks are interested in that, certainly ask a question later and I can chat about that a bit more. But again, so we have a view model here representing, calling into our shared code, returning the list of people and setting that in something that's observable from our UI. And our UI then in that case we'll start with our person view. Again, if you scratch below the surface, very similar to the person view Kotlin function, composable function that we added in our compose code. Same concept. Instead of using a Kotlin function, obviously here we're using a struct. But very similar, instead of row column, we have HStack, VStack. We also have text. Slightly different approach to modifiers, alignment, styling, for example. But among other things, what I really want to get across in this talk is that, Kotlin and Swift are very similar, very easy to read. If you understand one, you can certainly at least read the other one. If not, obviously make changes to it as well. But likewise, with this convergence on declarative UI frameworks now, we can see that as a SwiftUI developer, as a Compose developer, I can very easily, understand and make changes to the other on the other platform as well. And similar to Compose, we're going to add in something that represents our screen as a whole. And again, we're sort of pulling in our view model here. Instead of lazy column 4, we're using list. Same idea though, we're iterating over all the people in the list, and we're delegating now to the person view here. And we have a navigation bar title, slightly different approach, obviously, to how the UI or how the title is shown. So I'm going to run that here. What it's doing right now, just under the hood, in the shared Kotlin Multiplatform module, we're using this plugin called Kotlin plugin. And that sort of sets up the plumbing between sort of our Xcode and our shared module, such that this is put in as a pod basically into iOS, such that whenever we build and run like we did just now, it will automatically invoke the Gradle, appropriate Gradle task to build that shared code module and build it as a framework then that automatically gets pulled in and used in our Xcode project. And anytime we make changes to the shared code, that will happen automatically. If we don't make changes to the shared code, that framework is available, and our edit, build cycle and Xcode will remain the same, or should be the same as if you're developing your iOS code as normal. You shouldn't see any additional delay from having the fact that we're using the shared code. So right now, just to sort of recap very quickly before we move on to the next stage, we have a shared code module here. It has a very basic API class representing our interaction to remote API endpoint to get back to people in space. We have a repository that wraps around that, and that repository is, as I said, is a surface layer from the shared code. It's what we're using on Android and iOS. In the case of Android, we're using an Android view model, which is pulling that in, and then that Android view model in turn is exposing data that is observed and used from Jetpack Compose. On our iOS, then, we're very similar. We have an iOS view model, which is again is pulling in that data from that shared code, and again providing data that's observed and used in SwiftUI code. And hopefully, as I said, you start to see the sort of similarities here. So let's start making a couple of small changes. So the first thing I want to do is I'd like to show the image for the astronaut. Now, the API endpoints I'm using don't actually have any information about the image, any URL for the image. So somewhat of a hack in this particular example, I'm maintaining a list of URLs for the different astronauts. But it's a it's a good segue, because by doing that, we're doing that in the shared code. We're doing that in one place here. We're exposing from the shared code this get person image, which we're going to use on Android and iOS. And if and when we have a better approach to getting that image, getting that URL, we can change that in the shared code, and that automatically gets reflected and gets used in the UI code without any changes. Okay, so having added this method into the repository, we'll first of all we'll add a method into our view model. And then in our Jetpack Compose code, the observant of view may have noticed this commented out. So I'm going to comment this back in again. We'll start making use of that URL, that image URL, passing that down into the person view. And now we're going to make use of a third-party library to render that then. And that's going to render the image associated with that URL. And if we run this again. And we see the images shown there. It's UI looking a little bit better. And just very similarly, if we go to our iOS code and in our view model, we'll try to add in a method to get a person image, and we're calling this repository get person image. It's the same method again in our shared code that we called from our Android view model. And then in our SwiftUI code, in a very similar way, we'll comment this in. And we'll likewise use a wrapper that I have here, which again renders an image based on the URL. But just as that's running, we can see below, for example, the logging that from the HTTP client library, the Ktor client library that we have, logging the request that we made. And here we go. Okay, and again, very similar. We're using the same same shared code to get back the image URL and then rendering it in a platform-specific way. So right now, our repository is pretty basic, and also we have a significant, I suppose, issue in our code right now that in our view models here, for example, we're making a one-shot request to get to people. If that data changes, for example, if we're using a WebSocket or we have some kind of polling mechanism where we're trying to periodically get back the data, and you'll see example in the repository that's in GitHub where we do that for the International Space Station position. We want to get something that we want to get our UI notified whenever that changes. And the model typically in a mobile application or other applications is that we'll do that. We'll poll or we'll get a WebSocket connection, and when we do that, we'll store it in the local database, and then we'll drive our UI from the database such that any changes to the database are automatically reflected in the UI. So we'll do something very similar here. I'm going to pull in some code here. I'll explain obviously what this is, but just to mention again that we're using this library called SQLDelight. SQLDelight is a multi-platform library. It's driven from kind of a definition like this, very SQL-like, as the name kind of implies, where we have sort of how to create, insert, and make queries to the database. And then there's a SQLDelight Gradle plugin then, which takes this and automatically generates wrappers for this. So if we go back to our repository, we see that we're making use of this these queries. These are automatically generated from that SQ file, and we're doing this in shared code. So what we're going to do now is instead of that one shot, we're going to, well, we're sort of taking it a little bit further. At least we don't, as I mentioned, we don't have that polling and we don't have that WebSocket connection. But at least we're taking the data and on startup, and then we're storing it locally in the database. And we're using these people and Swiss queries, which are automatically generated from the shared code, or from the SQ file. And we're doing this in shared code. So this same code will run on both iOS and Android. But one thing that it does show, though, is this another capability of Kotlin Multiplatform that is very important. And this is how we create the DB. So this is where we start to use expect actual. And this is a capability that Kotlin Multiplatform provides, where we can provide platform-specific implementations of certain pieces of functionality. So in this case here, in our shared code, we say we expect a function create DB to exist. And then, for example, in our iOS code, we can have an actual implementation where we use an iOS-specific class here to create the DB. And we do something similar on Android. And so you have that very nice combination where, you try and write obviously as much of your code as possible as multi-platform shared code, but then you can still delegate out. You sort of have this capability to use actual platform-specific implementations of that. And having added that, then we can then go into our view model, and instead of this one-shot request, we're now going to use one thing I forgot to mention. If I just go back to the repository for a moment, is that as well as sort of inserting the data in the database here, now we are exposing a method here that allows us to expose a query to the database and expose it as a flow that we can observe in our view model. So having done that, we can now collect that in the view model here. Now any changes to the database will automatically be reflected, will automatically cause this state flow to be updated. And when that's updated, that will automatically cause the compose state to change and the UI to be updated. So let's run that. Now, the UI is going to look exactly the same. The same functionality is going to exist. But now what I can do is I can open up Database Inspector in Android Studio. And this is representing the SQLDelight database and the table that we wrote to. And now, for example, if I was to change this, if I was to try and become an astronaut for a few seconds, spell my name right. You see that's automatically reflected in the UI here. So when the database changed, then the flow, the code that was querying the database automatically emitted an update that was collected in our view model, and our UI, our compose code, then changed and re-rendered. And for example, if I run this again now, we're going to, as the app starts up, we're going to use what's in the database. We'll see my name up here, hopefully. And then there we go, it changes as it got the data back from the remote API endpoint. It overwrote what was in the database, and then that was automatically reflected in the UI. And you do something similar in the case of what we would do for iOS. We don't have time to do, or it's outside the scope of what we can do today, but in iOS we'd add a method here that would provide a lambda or a closure, and then any change to the database then would be notified through that to the UI, but a very similar approach. So if I so that's pretty much it. I just show a quick slide here. Just if you're interested in the repository, that sort of tried to create a clash here. I'm not too sure what I came across, but the People in Space repository also has some implementations for watchOS, web, Jetpack Compose for desktop, and also macOS as well. So you're very welcome, obviously, to pull that down and try that out. Hit me on Twitter or wherever if you have any questions or queries. Any questions? And I say, if people don't have questions now, feel free, obviously, to pull on the repository, try it out. Message me on Twitter or whatever, and I'll try to reply as well. And just, I guess while waiting, if people just sort of formulating questions, I guess I'll sort of preempt one or two maybe. Okay, can we expect there to be something like Compose for web? So there sort of is. One of an engineer from JetBrains sort of tweeted about some proof of concept, I guess, that they've done at this stage of having Compose running on the web. So I don't know how soon we'll have it, but it certainly seems like that's a capability that's being built out. It's very interesting. In that earlier slide, I left out the web part. I guess if you look at declarative UI frameworks across different client ecosystems, I guess React is probably one of the dominant ones there. And it's also declarative UI. But very interesting to have the Compose capability on web as well. Do you use KMP in production? So I have app in the Play Store, which I'm in the process of migrating over. Sorry, yeah, actually the app in the Play Store right now is using KMP. What I'm in the process of migrating over is actually the UI over to Compose, and we'll be hoping to update that soon. In general, KMP is being used in production. There's JetBrains, and if you follow TouchLab as well, they sort of published a number of case studies and examples of that. One of the critical things about KMP, I think, that comes into play here is that that ability to use it incrementally. You can pull it in, start bringing it in for some sort of very basic, maybe data model, or as we saw today, a remote API endpoint. Get your process in place, in terms of your, how you organize your code repository, how you organize your build process, for example, and then sort of build up from there. How do you see multi-platform going? Do you think Apple, Google, and JetBrains should collaborate? I don't see Apple and Google collaborating anytime soon. On the other hand, Google and JetBrains do and have been collaborating on a number of fronts. It's an interesting one. Android, Google is fundamentally in this context, focused on Android. JetBrains is obviously looking at a broader picture in terms of more platforms. Having said that, though, Kotlin Multiplatform is something that I see Googlers tweet about a bit and talk about a bit. So, I definitely see that. And there's other dimensions to Kotlin Multiplatform that aren't necessarily, maybe not as obvious. We look at Kotlin Multiplatform across various clients, but you can also, for example, share code between a server and client. You can have an Android, and there's examples of this out there as well, where you have an Android client and you have a backend, maybe using something like Ktor, for example, as the backend service, sharing code using Kotlin Multiplatform. Does using KMM affect app size as compared? So app size is something I think that's definitely evolving. It has improved a lot. I've seen there's a few studies out there that have kind of looked at sort of what the app size is like. I see it as something that will improve significantly. And I think even with Kotlin 1.4, there was quite a big improvement. The whole multi-platform Jetpack Compose looks somewhat complex and consumed for starters. One can learn and test Swift in Xcode, which runs in macOS only. Yeah, there is that. The other dimension, I think if you're interested in multi-platform and Jetpack Compose, the other interesting dimension to it, which has kind of emerged recently, is Compose for desktop. And as I mentioned, you can share code with the backend as well. So if you're interested in sort of trying out multi-platform, don't necessarily want to use it in an OS, Mac OS or iOS environment, you can also use it on develop and share code in. There's a sort of interesting segue, by the way. There's sort of multiple levels of sharing here in that context. Where we have our non-UI code shared with Kotlin Multiplatform, and then we can start to use Jetpack Compose for desktop, Android, and potentially web, as mentioned. And then we start to share our Compose code across those platforms as well. It's very interesting. Do you think clean architecture could help with KMM? It's a interesting question, and I think I could go about answering it in a couple of different ways. One of the things that KMM and Kotlin Multiplatform in general, one of the advantages of it really is that it doesn't force you down a particular architectural path. if you look at other approaches to sort of cross-platform, it's sort of really all in. You have to buy in and you have to use the whole approach. For me, the big advantage of KMM is that you don't have to do that. You can continue to use whatever particular frameworks and architecture you want to use. Now, having said that, the more you align, maybe the more opportunities that arise from shared code. If you're using MVVM or MVI, for example, and there's a whole other discussion, for example, about whether you pull some of that code into shared code. I think the talk after this, I think, is going to talk about that. But that flexibility exists, and you can use it for as little as much as you want. Okay, I think the fact the slide's coming to an end, I guess, coming closer to time. I think there had been a question there about the link to the repository. I'll post it in here. Also, if you my tweet, J O'Reilly is my Twitter. I'll post there as well. But I'll check on the platform here. I hopefully should be able to paste in the link for the URL as well. So thank you very much, guys.